Hello everyone, we have already learned about the sedimentation tank earlier. Today we start learning about sedimentation tanks. Sedimentation tank, similar to sand settling tank. But there are also many differences. Let's first take a look at the classification of sedimentation tanks. Sedimentation tanks can be divided into horizontal flow sedimentation tanks, radial flow sedimentation tank and vertical flow sedimentation tank. It is classified based on the direction of water flow. Horizontal sedimentation type refers to the flow velocity in the horizontal direction. A radial sedimentation tank radiates from the middle to the surrounding areas. Vertical flow sedimentation tank, in a vertical direction. Let's take a look at the horizontal flow sedimentation tank first. Structure of horizontal sedimentation tank: inlet area, water inlet downhole, water inlet baffle, water distribution wall, uniform water distribution. Purpose of the intake area: to ensure uniform and stable water distribution. The water flow should not cause stagnant or short flow areas. Ensure full utilization of the entire sedimentation tank. Stability of water inflow: directly related to the entire advection type. Removal efficiency of sedimentation tank. Secondly, the outlet area, effluent scum baffle, catch basin, outlet channel. Collect water evenly. If the water collection is uneven, can easily lead to the outflow water will carry away some suspended solids, causing unstable effluent quality. Thirdly, sludge area, mud hopper and sludge discharge machinery. It is related to whether the entire sludge discharge process is smooth or not. Design of mud bucket. Design based on the viscosity and amount of sludge, the size and inclination of the mud bucket, and there are pipes for sludge discharge. Ensure smooth mud discharge. Third, the function of the water inlet baffle. It can dissipate energy and evenly feed water. It can stabilize the inflow water flow. The function of the water outlet baffle is to block the scum on the water surface, and oil substances. It can prevent these scum and oil from flowing with the effluent water. Flowing into the next process affects the operation of water processes. Next, let's take a look. Sludge discharge method of horizontal sedimentation tank. The first one is the hydrostatic method. Through water flow, static pressure, direct control of pressure, remove sludge. The sludge that has settled into the mud hopper is discharged. Mechanical sludge discharge method. It's through a mud scraper or a suction pump. Directly scrape or suck away the sludge. This is the sludge discharge method of the horizontal flow sedimentation tank. Commonly used. Let's take a look at the radial sedimentation tank. Characteristics of radial flow sedimentation tanks. It's just a floating sedimentation tank. It is a circular pool with a larger diameter. Then the wastewater passes through the inlet pipe, after entering the central water distribution pipe through the holes on the pipe wall and the Y-shaped periphery. Perforated rectifier baffle. Then it flows radially towards the surroundings of the pool wall. Then it passes through a stable flow weir or submerges the orifice. Merge into the water collection tank and discharge. Sludge settling at the bottom of the pool. Due to the bottom scraper installed on the truss, scrape into the mud bucket with traces in the form of spirals. Further use of static pressure or sludge pump discharge. This is usually done through mechanical and pump pressure methods. To carry out joint sludge discharge, radial flow sedimentation tank. Thirdly, due to the fact that the flow section extends from the center to the periphery, continuously increasing, horizontal fractional velocity, gradually decreasing. Therefore, its suspended solid particles settle. The trajectory shows a drooping curve. Circular magnet variable speed water flow mechanical sludge discharge. These are some characteristics of radial flow sedimentation tanks. Centripetal radial flow. Shortcomings of traditional radial flow sedimentation tanks: intermediate inlet area, minimum water flow cross-section, high water flow velocity, affects processing effectiveness. Therefore, a radial flow sedimentation tank is generally used. Surrounding water inflow. The way the surrounding water flows out to change this disadvantage. Increase in inlet and outlet cross-sections. Minimum flow rate. Can improve processing power. This usually uses a radial flow sedimentation tank. The following is a schematic diagram of its structure. Radial flow sludge discharge facility. Here are two common radial flow sludge discharge facilities. One is through siphoning, a sludge discharge method that does not require power. Another method is through pumping, direct sludge discharge operation. Both are relatively stable. During the operation of radial flow sedimentation tanks, intermediate water inlet, operation mode of peripheral water outlet, stable operation. Next, let's learn about vertical flow sedimentation tanks. Vertical flow sedimentation tank, mostly used in small flow wastewater. A separation method for flocculent particle suspension. Circular in shape, or regular polygon. Its upper part, the cylindrical part, is a settlement zone. The lower part of the inverted circular table is a sludge area. There is a buffer layer of 0.3 to 0.5 meters between the two. Operation of vertical flow sedimentation tank. Wastewater enters the central pipe. After flowing out from the pipe orifice, by using the obstruction of the reflective plate, distribute it in all directions, and slowly rise vertically along the cross-section of the settlement zone. Particles with a settling speed greater than the flow rate sink into the sludge area. The clarified water flows through the overflow weir and enters the collection tank for discharge. There is a semi-submerged baffle on the inner side of the overflow weir, to prevent scum from being carried out by water. The maximum diameter of the vertical flow sedimentation tank shall not exceed 10 meters. To ensure the vertical movement of water flow, ratio of pool diameter to settlement zone depth not more than 3. In a vertical sedimentation tank, the horizontal velocity of water flow is 0. Particles with a settling velocity of as in the influent. The actual speed in the pool is vector sum of as and horizontal flow velocity v. The conditions for particle separation are: as must be greater than v. Particles with as less than or equal to v. Always unable to settle. Therefore, the efficiency of its settlement, compared to a horizontal flow sedimentation tank with the same surface load, reduced. Its characteristic is that the water flow moves from bottom to top. Small pool diameter. The burial depth of the pool body is large. Low processing water volume. However, it occupies a relatively small area. This is the structure of a vertical flow sedimentation tank and its corresponding characteristics. You can see that there is a water baffle inside. Separation of mud and water from the middle to the surrounding area. Inclined plate and inclined tube sedimentation tanks. Principle of shallow pool settlement. Equipped with an ideal sedimentation tank. The length, width, and depth of its settlement zone are L, B, and H, respectively. The surface area is A. The treated water volume is Q. Surface load is Q0. The settling velocity of particles is U0. It can be obtained that Q equals U0 times A. So, under certain conditions of A, if Q is increased, then U0 increases proportionally. Corresponding reduction in cost reduction efficiency. On the contrary, it is necessary to improve the efficiency of cost reduction. Then U0 must be reduced. As a result, the flow rate Q decreases proportionally. If the height of the settlement zone is divided into n layers, then n, lowercase h, shallow settlement unit equal to capital H divided by n. So, under the condition that Q remains constant, sedimentation depth of particles, reduced from uppercase H to H ratio n. Thus, the settlement efficiency E is improved, increased by n times compared to the original. Obviously, the more shallow layers separated, the more the sedimentation efficiency E value increases. This is the theory of shallow sedimentation. Install inclined plates or pipes in the sedimentation tank. Above the inclined plate, it is the discharge area. The inclined plate area is a sedimentation zone. Then below the inclined plate are the inflow area, and the sludge area in sequence, can ensure sufficient sedimentation zoning. When the sedimentation tank is working, water flows between inclined plates or inside inclined pipes. Sludge settling on inclined plates or pipes automatically slide into the mud hopper by gravity. The commonly used perforated rectifier wall for water distribution in inclined plate sedimentation tanks. Stable water quality. Perforated pipe or submerged orifice for water collection. Shallow holes can also be set on the ground in the water collection tank. Make the water collection more uniform and stable. Commonly used for mud collection. Multi-bucket perforated tube. Common devices rely on static force and pump suction for sludge discharge. According to the water flow in the settlement zone, relative movement direction with sludge, the inclined plate sedimentation tank can be divided into opposite flow. Three forms of co-flow and transverse flow. Application of sedimentation tanks. Below is the application of sedimentation tanks in industrial applications in agriculture and daily life. It is widely used. This concludes today's class. Thank you all.